very sorry I have to cut this lecture for only 15 minutes or actually 18. But I'll try to make it fit. Okay. I had to run going here today. Okay, so today, okay. Episode 12 of the family exposition of math. Last lecture we talked about the relation between fucking around and finding out. So, good morning, Jad. Today's lecture, we're gonna talk about abstract paintings. So, this is not the art style that we're talking about, but rather we're talking about abstract paintings in the way of making a painting. So, of course, there's many ways of making artworks. One way is to sculpt stone. That's what the ancient Greeks did to commemorate and make their philosophers and mathematicians and whatever known to this day. Of course, there's regular painting with a paint and brush, the thing that the great painters of all time did, like Michelangelo, Van Gogh, what they used to make artworks. But today we will be using abstract algebra to construct paintings. So, but the painting that I'm talking about here is not a painting in a traditional sense, but rather it is a collection of mathematical objects whose representation as a whole gives us a picture in R space. So definition. A painting. Oh my god, my markers don't work. Where's the red one? Where's the red one?
Oh, here.
Oh, there it is. Oh, is that erasable? That might be permanent. Let's check it out.
Let's check it out and see.
Yeah, check it out. Is it?
Oh,
Yeah, okay, thanks.
Okay, it's erasable.
Okay, thanks. A painting. Why is it so thin? Okay, we'll have to make do. A painting is a collection of mathematical objects objects whose representation can be projected into Rn. Mostly, the examples I'm going to give you guys today mostly deals with R2, two-dimensional Euclidean space, and R3, three-dimensional Euclidean space. We're assuming the Euclidean metric, of course, you know that the usual norm that maps R2 onto R. We're assuming this metric exists and that we're working with the ring R plus and then the multiplication operation. Shen, you look horrible. Okay, you look horrible. Your haircut is trash. Okay. If I'm not gonna get sidetracked any further. So this is our definition of a painting. Of course.
It's true.
Okay. So, what's an example of this? Of course, you're gonna need some familiarization with some abstract objects in order to construct a painting. Now, an example, I've done some examples.
Normal? Ask Kyle. I think he's part of Rena's cluster.
Is this normal?
Yes.
Yes.
Oh.
Yes, it's normal, Chen. You know this. Chen, I don't have time for this. I really don't. I'm sorry, I really don't.
Let's discuss. I'm just watching.
I really don't have time, and this is permanent, by the way.
I don't think anyone's minding. Wait,
Don't tell me. This is permanent, by the way.
wait.
Yes, it's permanent.
Oh shoot. Oh great.
Right, no, no.
Congratulations.
Oh my god!
Idiot, it's permanent.
Oh. Well, there goes that. Oh my. Oops. Well, what is done is done.
Okay.
I don't know, it worked so well the first time.
Yeah, it did. Okay. Whose?
Why did you use a permanent marker in the first?
I didn't know.
We didn't know.
Yeah, and then just
Is it?
It's still there.
it's still there.
It's sit for it.
Fudge.
Don't worry, come on, keep going, keep going. There's just no more lectures.
No,
So,
but this is a blooper.
so it's paintings and
Yeah,
abstract paintings and mathematical equations.
it's they can be represented. Sit down, Chen. If you're gonna listen to like sit down.
Okay.
Yeah, sit down.
Not there.
Jen, Thomas, stop distracting you.
Okay.
Bye.
Okay. So even just a simple object like a simple circle S1 is already a painting, because notice that we can represent S1. We can represent S1 as a subset of R2. S1 is a subset of R2, and is in fact defined to be the set of all points x squared plus y squared equals r squared. Such that, well, these three numbers are part of R. So that's the definition of S1, or a circle. And yeah, this is an example of a painting already. But of course, I have a paper that catalogs some examples of it. I discovered this thing just a night or so ago, I believe. Was thinking about, what if we use some abstract objects, like I say, well, yeah, S1 or a square, which I'm not using this, or a square which we define to be, well, is a cross product between an interval and itself. So AB, N, is a hypercube, of course. Well, if it's just AB, it's just a regular line. If it's AB squared, or AB cross AB, that's a square, and then AB cross AB cross AB is a cube, and so on and so forth. This is also already a painting, because of course we can represent this as, they're visual objects for each n, for each n. So yeah, but a true painting is when we actually compose these two together. So when we take their disjoint union, or maybe just their union, it doesn't necessarily have to be a disjoint union. When we do take their union or their disjoint union, we have a collection of objects now. And we can think of it as either maybe the cube, or whatever the heck this is, maybe a line or a square, is attached to this circle. So we can think of it like this. Or it could just be these two but separated. But of course they exist in the same space, so we're drawing them next to each other. So yeah, this is a painting. Now, what was I going to say about paintings?
Sir and Ed,
Yeah,
So-
Niccolo.
you're saying that that these equations can be used to represent like certain shapes, which can be used to construct a painting.
Yes.
So like in other words, you can say there's like an equation that you can use to paint a human. Like let's say I want to paint like a human person. There's an equation for that.
Yes.
If I want to replicate the Mona Lisa, there's make an equation for that.
Absolutely. That's called a Fourier series, which uses a bunch of vectors that are rotating, right, in a circle. You put those vectors like tip to tip, and then if you just adjust the parameters just a bit in the original equation, when these vectors rotate, they trace out a pattern to the Fourier series. It's amazing, I swear. Triple One Bro made a video on it, so you should check that out. Anything else?
So is it like the same thing as decimals, where you construct equations together and make a shape?
Yeah, well, the thing is, the relation between equations and objects in mathematics, especially abstract algebra, is much more, um, it's higher than you think it is. It's more of that the objects themselves are a representation of the equations, or there are a way for us to visualize it, because the equations themselves, I can just think that this is an object in itself, and this is not a circle. I don't think of this as a circle, but its own object, its own abstract object, and x squared, y squared, and r squared, for me at least, can, or for someone who wants to think of them as nothing else but their own thing, can think that way. But of course, we all know that this is intuitively a circle, because all points such that their squares, or the sum of their squares equals some radius squared, is a circle. Because, of course, when we try to look for pairs of points that satisfy this equation, of course, for any r over here, we think of a circle, or we see a circle. Those trace out a circle. So that's what we think of this. But there could probably be other ways of representing this. This can be a slice. This can be a slice of a solid ball. This can be a slice of a shell, a three-dimensional shell, and well, many other things. This can be a subset. In fact, this is a subset. As I said, this is a subset of R, or two-dimensional space. All right. Is that all the questions? Yeah. Okay. So one of the paintings I did, I haven't really encoded it yet, or actually I did encode it last night. Is, oh dear, I'm running out of time. Yeah, I don't have much time on this, but it is like, it's the best way to visualize these things is to, well, of course, think of the individual objects, and then you think of them separately. You think of them separately, as separate objects. You have a solid ball or maybe a cube, and then in the way that's most intuitive to you, based on the title of the painting, you put those those objects together in such a way wherein they give you the picture of what the title is supposed to encompass. So let's say that my painting is called A Death in Venice, right? Or Sorrow in Pajamas. When we think of the title, we think, oh, maybe it's a person who's sobbing in his bed, right? For Sorrow in Pajamas. So therefore, all the objects that I list down, we're gonna think of them as they make up a picture, a geometric person, a person whose head looks like maybe an ellipsoid, the torso that looks a bit like a rectangular prism, or arms that look like cylinders. In fact, that's what the entire painting is composed of in the abstract sense. And we just take their union, to put them into one object. And of course, you just think of them, whichever is most intuitive to you. Of course, someone can misinterpret the entire thing and think, oh, it's maybe this, it's not really a person sobbing in their bed or what. But the fact that it's a person sobbing on his bed is what makes it, what it really should look like. Okay, so, yeah, I don't really have much time because I arrived late today, so, yeah, I guess if I'm gonna expound on this further, it would be in the paper or in a future F.E.M episode. So, yeah. Any more questions? Yes, Nico.
So Renette, do you have a picture?
Good morning, guys.
Morning, guys.
Picture that you painted
Hello.
on the pictures?
Huh?
You have a picture that you painted on the picture?
Oh, yes. I have a paper on that. So you can check it in the description when I upload this video. I'm gonna put the link to the paper there. But note that there will be no pictures there. It's an exercise to the viewer or the reader for the paper to visualize it in their minds. So yeah, that's it.